Friends, today we will discuss about the periodic classification of elements. Now, what do you mean by classification? Classification means grouping of the elements on the basis of similarities in properties. Their properties are similar or are arranged in the group on the basis of similarities in properties. What is the need of classification? It is difficult to study each and every element individually and to know its properties and uses. Therefore, they have been classified into groups on the basis of their similarities in the properties. Now, what is the basis of the classification? Classification is done on the basis of similarities in properties so that the systematic study could be made about them. First, this is done by the Dabiriner law of triads. When the elements are arranged in the group of the three, triads mean three. When the elements are arranged in the group of three in increasing order of atomic masses, it is based on the atomic mass. The middle element of a group has the atomic mass and property roughly the average of the other two elements. You can take the example of this lithium, sodium and potassium. If we measure the atomic mass of these two elements, then the average of their mass is equal to the sodium in between element. When the elements are arranged in the group of three in increasing order of atomic masses, the middle element of the group has the atomic mass and property roughly the average of the other two elements. Average atomic mass of first and third. First is 7 and third is 39 and divided by the 2 and it is roughly equal to the middle element, that is sodium, and this is atomic mass is 23. Now, what is the importance of this classification? The above classification of elements into triad had a great significance in predicting the atomic mass. It helped in predicting the atomic mass and properties of the middle elements. Even in these days, these elements resemble in their properties. The limitation of the Dabiriner triad, all the elements could not be classified into the triad discovered at that time. All the elements could not be discovered at that time. Only a limited number of the elements could be arranged in such a triads. Now, second is the Newland law of octaves. Now, Newland studied it. Newland arranged elements in order of their increasing atomic mass. It states when an element are arranged in increasing order of atomic mass, the properties of the eighth element are a kind of repetition of the first, just like the notes of the music. If we are arranged the 8-7 element just like the note of the music, sa re ga ma pa dha ni sa, and then again first and eighth properties resemble with each other. Example, lithium, sodium, potassium resemble each other with the properties. Arrangement. The need of arranging element into the vertical column called the groups and the horizontal rows called the periods thus became evident, and in doing so, periodicity in their properties could be observed. What was the limitations of the Newland law of octaves? All the elements discovered at that time could not be classified into the octaves. Periodicity of the properties. Periodicity means repetition. After the regular interval of the time, the repetition of the similar properties after a definite interval is called periodicity in properties. Now, next third is Mendeleev classification. Third, Mendeleev studies the periodic table. Mendeleev arranged 63 elements known at that time on the basis of similarities in their properties. That is, on the basis of similarities, the formula of their oxides, hydrides, etc. formed by these elements. He observed that most of the elements were placed in the increasing atomic mass. It was observed that there is a reoccurrence of elements with similar physical and chemical properties after a regular interval or after a regular period or periodicity is there. That is, every eighth element had properties similar to that of the first element. Mendeleev periodic law. It states that properties of the elements are the periodic functions of their atomic mass. It depends on the atomic mass. Properties of the elements are the periodic function of their atomic mass. Advantage of the Mendeleev periodic table. He could classify all the 63 elements discovered at that time on the basis of similarities in property. He left gaps for yet to be discovered elements. He predicted the properties of undiscovered elements and thus helped in the discovery of these elements later on. He named them by prefixing a Sanskrit numeral eka for 1, divi for 2 and tri for 3, etc. to the name of preceding similar elements in the same group. Example, eka boron, eka aluminium, etc. It helped in the correction of the atomic weight of certain elements on the basis of their position in the periodic table. What was the limitations of the Mendeleev periodic table? Although most of the elements were placed in the order of increasing atomic masses, increasing order could not be maintained in all cases. Mendeleev periodic table did not provide place for the noble gases because they were discovered later. There was no place for the isotopes in the Mendeleev periodic table, although they differ in their atomic masses. Modern periodic table. Henry Moseley, an English physicist, found that the atomic number was the fundamental property of the element and not the atomic masses for the classification of elements. The modern periodic law. Properties of elements are the periodic functions of their atomic number. It is depend on the atomic number and not on the atomic mass, which was discussed by the Daberainer, Newland and the Mendeleev. They were saying that it is based on the atomic mass, not the number. But modern periodic law states that the properties of elements are the periodic functions of their atomic number. Long form of the periodic table. This was the modern periodic table. Elements are arranged in the increasing order of their atomic numbers, not on the atomic mass. Elements are arranged in increasing order of their atomic number. The predictions of properties of elements and their compounds can be made with the precision. All drawbacks of the Mendeleev periodic table vanishes when the elements are arranged on the basis of increasing atomic number. When modern periodic table was arranged on the basis of the atomic number, then all the drawbacks were vanished. What was the main feature of the long form of the periodic table? It shows arrangement of elements based on the modern periodic law. There are 18 vertical columns, these are known as groups, and there are 7 horizontal rows, these are known as periods. Elements having similar outer electronic configuration, that is, they have having same valence electron in the outermost shell in the same group. In periods, number of the electron in the outermost shell of element increases gradually. Just hydrogen 1, helium 2, 1 electron increase, then lithium 3, 1 electron increase, beryllium 4, 1 electron increase, then electron increase, element increases gradually. Now this is the long form of the periodic table. Here is the hydrogen and this is the first group. Now second group is starting from the beryllium and 13, 14, 15, 16, 17, 18 group. They are named according to the first element. Here is the boron, then 13 is called the boron family, and carbon, carbon family, nitrogen, nitrogen family, oxygen, oxygen family, and Fluorine, this group is called halogen. 17 group is called halogen and 18 is noble gas. Now, first group are called the alkali metal because they form the alkali. And second group is called alkaline earth metal. They are obtained on the earth crust. And these are called the 3 to 12 are called the transition element because they transit from the metal to non-metal. These are called the transition elements. And next at the lower side is inner transition element because they lies in between these elements. They are the inner transition elements. There are 4 blocks. 1 and 2 group is called S block. 13 to 18 is called P block and 13 to 12 is called D block and lanthanides and actinides are called F block and they are the inner transition elements. This is the long form of the periodic table. Periods. 7 horizontal rows are called the periods. First period contains 2 elements and this is called the shortest period. This is called the shortest period. And second and third period have 8 elements and this is called the short period. Fourth and second and third period both are called the short period. Fourth and fifth period they have 18 elements and both of these said to be long period. Sixth and seventh period have 32 elements. Sixth period is called the longest period and seventh period is incomplete. Atomic size. What do you mean by atomic size or atomic radii? Atomic size means radius of the atom. It is defined as the distance between the center of the nucleus to the outermost shell valence electron of an isolated atom. It is defined as the distance between center of nucleus and outermost shell, that is valence electron of an isolated atom. Covalent radii defined as half of the distance between the center of nuclei of two atoms bonded by a single covalent bond. Variations of atomic size in group. Atomic size generally increases from top to bottom in a group because if we look at here, then here are the number of shell is increasing. In lithium 2 and 1, only 2 shell and 1 is the valence electron, sodium 281, potassium 2881. Each and every element one shell is increasing. That's why size is increasing from top to bottom. Due to addition of the new shell, number of shell go on increasing. Now variation of the atomic size along a period. If we goes along the period, then atomic size goes on decreasing along a period from left to right because hydrogen, helium, lithium, beryllium, boron, then only one electron is increasing and in the outermost shell, and due to this increase in the number of the electron, nuclear charge increases, which pulls the electron towards itself, and the force of attraction between nucleus and valence electron increases. Therefore, atomic size decreases. Lithium, beryllium, boron, carbon, nitrogen, oxygen, one electron is increasing. That's why size is decreasing. Tendency to lose or gain electrons. Chemical nature and reactivity of an element depend upon the ability of its atom to donate or accept electron. Variation of tendency to lose electron down a group from top to bottom. Tendency to lose electron goes on increasing because size is continuously increasing from top to bottom. This is due to increase in the distance between the valence electron and nucleus as the atomic size increases down. The force of attraction between the nucleus and the valence electron decreases. Therefore, tendency to lose electron increases down the group. Tendency to lose electron decreases down a period. from left to right because decrease in atomic size. Reason: due to decrease in atomic size, the force of attraction between the nucleus and the valence electron increases. Therefore, the electron cannot be removed easily. Now, variation of tendency to gain electron. Gain electron down the group from top to bottom goes on decreasing due to increase in the atomic size or force of attraction becomes less. Of tendency to gain electron along a period increases from left to right. This is due to decrease in the atomic size and increase of the force of attraction. Metallic character increases from top to bottom. This is due to the loss of electron. Non-metallic character decreases from top to bottom because decrease to gain electron. Due to increase in the atomic size, left to right non-metallic character increase due to increased tendency to gain electron. Thank you.